record. Okay, so this is 4.2, y'all. 4.2 is prime and composite numbers. Okay, so the first thing we're going to talk about is something called prime factorization. And it says composite numbers can be expressed as the product of two or more whole numbers that are greater than 1. For example, 18 is 2 times 9, or 18 is 3 times 6, or 18 is 2 times 3 times 3. Okay, it says each expression of 18 is a product of factors called a factorization. Now, there's something called a factorization that only has prime numbers, and that's what we call a prime factorization, okay? So it says to find a prime factorization of a given composite number, we're going to rewrite the product as two whole numbers that are bigger than 1. We're going to continue the process factoring these numbers until all factors are prime. Okay, so this is what we're going to do, y'all. We're going to write something called a factor tree for the number 260. Okay, so when I think of 260, I want to think of two numbers, any two numbers that multiply to 260, that it's not 1 and 260. Okay, any two numbers. So a couple of things we can do here, y'all. It ends in a 0. So because it ends in a 0, I know it's going to be 10 times, say, 26, right? Now, what I want to do is I want to continue breaking down those two numbers, okay? So look, let's break down the number 10. What two numbers multiply to 10? 5 and 2, right? Okay. And y'all, what I'm going to do here, I'm going to circle the 5 and I'm going to circle the 2. The reason I'm circling those numbers, I can't break them down anymore, okay? Those numbers can't be broken down. They're prime numbers, all right? Now, let's do the same thing for 26. 26 is an even number, so I know I can at least divide it by 2. Does anybody know how many times 2 goes into, say, 26? 13, right? Good. Okay, just like we did before, y'all, I'm going to circle the 2. And you know what? I'm going to circle the 13 because we can't break down 13 anymore, okay? So the way we write the prime factorization of 260, we're going to write it like this. We're going to say, look, how many 2's do we have? We have 2 of them. So I'm going to write it as 2 squared, and then times 5, and then times 13, okay? So this is what we call the prime factorization, and we're making what we call a factor tree. Why do we call it a factor tree? Because it looks like a little tree, right? These little branches kind of breaking down at the bottom, all right? So look, let me keep scrolling along here, and I'm going to do part A for this problem, and it says, fill in the missing numbers in the factor tree. Okay, so let's think about this, y'all. We're going to fill in the missing numbers. I want you to look at the numbers at the bottom, 2 and 7. When they're like this, that means that we're going to multiply 2 times 7 to get this number here. So then wouldn't that number there have to be 14? And then I'm going to do the same thing here. Look, I'm going to take 5 times 14. So look, let me grab my calculator. Whoa, maybe not that much. What's 5 times 14? 70? Okay, let me just, there we go. See if I can do this too. Okay. Yeah, so 5 times 14, I believe you. It's 70. Yes, it is. So we're going to put a 70 right here. And then we're going to take 3 times 70. That should give us something like 210, right? Okay, so we found the missing values, okay? Now, there's a part B. Part B says, how could you find the top number without finding the other two numbers, okay? So meaning, how could I find this number without having to find that number and that number? The way we would do this, y'all, we would take 2 times 3 times 5 times 7. I wrote them this way, y'all, not for any particular reason other than I was just writing them in order from smallest to biggest. The order in which you put them in is not really important, okay? So let's think about what do we do here? We multiplied, right? This is all multiplication. So we multiplied these numbers down here, which are products of prime factors, okay? So if we're multiplying, we are finding the product of all 4 prime factors determined from the tree, okay? So that's what we did there. We just multiplied those two numbers, and that's how we would end up with the number 210, okay? All righty. So I'm going to keep scrolling along here, and look what we're going to do. We're going to find the prime factorization of the number 2,205. Okay, so y'all, one of the things that we talked about is how do I know if I can divide a number by 2 or by 3 and that kind of stuff. So if y'all remember, and I'm going to put it up here because I know I have it somewhere. Let me come back this way. Let me close that up. I'm going to get my multiplication chart, y'all, because again, if I'm teaching this kind of stuff to kids, this is what I would use a whole lot, right? And obviously, you know, I think when I want to say when I was in elementary school, it was mainly like a 12 by 12, right? So I didn't necessarily have all the numbers, but so I'll even just kind of do it this way. But let me come back to my notes. Okay, so look at the number 2,205. Y'all, when I look at this number, I know I can divide it by 5 because a number can be divided by 5 if it ends in a 0 or 5, right? So what I would probably do is I would do this. And I'd say, look, I can divide it by 5. So let me get my calculator, 2,205. Let's divide that by 5, and I'm coming up with 441. Okay. Now, another thing we said when we talked about this, I think it was in chapter 3, I think it was. I don't know, it was either towards the end of 3 or 4.1. But we said we can divide a number by 3 if we take the digits and add them up. 4 plus 4 plus 1 is 9. If we can divide that number by 3, then we can divide this number by 3. Okay. So look, let me do this again. Let's divide that by 3. 147. Okay. I'm going to play that same game again. I'm going to say, look, what's 1 plus 4 plus 7? That's 12. I can divide that by 3, so I can divide this thing here by 3 as well. 49. Okay. Anybody know what two numbers multiply to 49? 7 and 7, right? Okay. So it's telling me, okay, what's the prime factorization? So y'all, the way I'm going to do this here, I'm going to look at each of the ends of my branches, okay? I'm not looking at 49 because we broke down 49. I'm not looking at 147 because we broke that down. The order in which you put it, it's not really important, but I always put my numbers from smallest to biggest. So first question, how many 3s do we have? We got 2 of them, right? So look, we're going to put 3 squared, and then we have a 5, and we have 2 7s, so we're going to put a 7 squared. Okay. Okay, so if I look at the next problem that I have here, it says, find the prime factorization of the following numbers, okay? So guys, one thing I want to emphasize, and I'm going to kind of scroll back because I think it's up here somewhere. Okay. Prime numbers are going to be bigger than 1. Okay, 1 is not a prime number. It's not composite either. It's kind of like a special case. So when I write my prime factorization, guys, I'm never going to use the number 1, okay? I just wanted to mention that because when I look at this problem here, and what I want to try to do is break this number down, okay? I'm not going to worry about the 1 because it's not a prime number, okay? I'm going to leave 2 alone, and I'm going to leave 3 alone because those numbers can't be broken down. But for instance, the number 4, how can I break it down 4? 2 and 2, right? Okay, I'm not going to worry about 5 because I can't break it down, but I'm going to break down 6. I can break down 6 into what? 2 and 3? Okay. Can we break down 7? No, so we're going to leave that one alone. Y'all, we can break down 8. 8 is 2 times 4, but what's 4? 2 times 2, right? Okay. And then 9, we can break down 9 into 3 and 3. And then can we break down 10 at all? 2 and 5, right? Excellent. Okay, y'all, this is what I'm going to do now. I'm going to come back to my numbers, right? And I want to count how many 2s do I have, okay? So look, there's 1, 2, 3, 4, 5, 6, 7, 8. So look, y'all, I'm going to put 2 to the 8th, okay? I'm going to do the same thing with my number 3. I want to figure out how many 3s do I have. Yeah, I counted this one too. So I went 1, 2, 3, 4, 5, 6, 7, 8, right? And I'm going to do the same thing for the 3s. Good question. So look, 1, 2, 3, 4. So 3 to the 4th. And then what else do we have? We have a 5, okay? We have a 7, okay? And we have what else? What other number have I not counted yet? And you know what do we have? But remember, we broke down the 4 into 2 and 2. And look, guys, I have this 5 here, but don't I have that one over there too? So I really have 2 5s, don't I? Okay, that was my bad. All right, does it look like we've counted all the numbers? Right, because remember, we're not looking at 6 because we broke it down. We have the 7 right there. We're not looking at 8 because we broke that down. We broke down the 9 too. So this right here, y'all, should be my answer. 2 to the 8th, 3 to the 4th, 5 squared, and a 7. And I'm going to come back over here and I'm going to say, hey, that looks like choice what? Choice D, right? And this is all I'm doing, you guys. I'm just breaking down my numbers. All right. So I have another one here. We're going to do the same thing. We're going to break down these numbers here. So first thing I'm going to do, guys, I'm going to look at my number 35, okay? I want you to think about the number 35. I know it's to the third, but what two numbers multiply to 35? Anyone know? And if we need to, guys, we can come back to our table. 5 and 7, right? Right here, 5 and 7. Perfect. Okay. So look, y'all, I'm going to put a 5 here. I'm going to put a 7 right there. Okay. Now look, 55. What two numbers multiply to 55? 5 and 11. Good. Okay. Now, the next thing I have here, I have the number 9. Do you guys agree that 9 is 3 times 3? And isn't 3 times 3 the same thing as 3 squared? Right? Okay. So y'all, there's a rule. These are just rules of exponents, okay? And I'm going to walk y'all through them right here. The rule of exponents, one of them says, look, if I have two numbers and they're being multiplied and that's being raised to a power, like 5 times 7 to the third, I can write that as 5 to the third and 7 to the third. So I'm putting that power on both of them, okay? Now, I'm going to leave this 5 alone. I'm going to leave that 11 alone, okay? There's another rule of exponents that says if I have a number that's being raised to a power and I raise that to a power, then what we can do, y'all, we can multiply those powers together. And that gives me a 3 to the 22nd power, okay? Now, what I'm going to do, y'all, I'm going to put my numbers in order from smallest to biggest, okay? So look, we have a 3 to the 22nd. The next smallest numbers, y'all, I have is 5s. But I want to show you something. Here I have a 5 to the third. Here I have another 5. That tells me that I have 5 to the 4th. Because if there's 3 5s in one spot and another 5 in another spot, then there's a total of 4 of them, okay? And then I still have a 7 to the third, and I still have an 11. And so I'm going to look at this piece right here, and I'm going to come back, and I'm going to say, okay, do any of my answers look like this? Yeah, it looks like D looks like the correct answer again, doesn't it? Okay. Okay. So look, let's take a look at part C and see if we can break this thing down. The next number I'm looking at here, y'all, is 293, okay? So look, let's try this. 293. Okay, so one thing I might do is I might say, look, let me take the number 293. Okay, I know I can't divide it by 2 because it's not even. I'm just going to check. I know there's little rules, you guys, but it's pretty easy if I just check this way. Okay, I can't divide it by 3. Okay, and I know I can't divide it by 5, but let me try 7. No, okay. And let me try, oh, I don't know. Let me try 11. No, okay. And let me try another number. And I'm going to tell you what numbers I'm trying. I want you to look at the numbers that I'm trying here, guys. So I tried 5, or I didn't try 5. I tried 7, I tried 11, I tried 13. I'm going to try 17. Okay, nope. I'm going to try 19. Nope. Okay. I'm going to try, say, 23. Nope. Okay. I'm going to try one more. 29. Nope. Okay, that number itself, guys, is a prime number. I cannot break down the number 293. It just can't be broken down. The only numbers that multiply to 293 are 1 and 293. It's already a prime number, okay? And then I'm gonna come back and I'm gonna talk to you about how was I like dividing it? Why was I trying those particular numbers, okay? So let's take a look at the next one. It says, choose the correct factorization of 100 to the 12th power. Okay, so first thing I want to do is I want to look at my number 100, okay? Do you guys agree that 100 is the same thing as 10 times 10, which is 10 squared? Okay, now, y'all, remember we had a little rule a little while ago. We said, look, if those things are being raised to a power, we can just multiply them together, okay? Let's see. The other thing I want to do now, I want to see if I can break down the number 10. What two numbers multiply to 10? 2 and 5, right? Okay. And then there's a rule on exponents, y'all, that says if you're multiplying two numbers together inside and there's a power, you can just raise each of those to that same power. So I have 2 to the 24th, excuse me, and 5 to the 24th. And here is my answer. Okay. Okay, so let me keep scrolling along here. And what I'm going to do, y'all, before I do this next problem here, I'm going to make a list. And I want to show you the list that I'm going to make. And you don't have to copy all of this part. I'll tell you the part that I really want you to copy, okay? Now, it's going to take me a little while to make this list, okay? So I'm going to go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, say 20. That's why I said I want you to copy this down, because it's a lot to copy. I don't even want to write it down because it's a lot to write. Where do y'all think I'm going to stop? Probably at 100. Yeah, we'll stop at 100, guys. I mean, we can make this list as we want it, as long as we wanted to, but yeah, I'm going to stop at 100. All right. Last one. Okay. What we're going to do here, you guys, is, does anybody know this word here? My writing is horrible, isn't it? Anybody know what that is? A sieve? A sieve is kind of like a strainer. I'm guessing that everybody here has probably made spaghetti at some point in your life. You boil the noodles, you drain them, right? The water comes out, you're left with the spaghetti. There's something called, there's a Greek mathematician, I don't remember the guy's name off the top of my head, but he made this thing called a sieve. And what we're going to do, we're going to find the first prime numbers between 2 and 100. Okay, so remember what prime numbers are. Prime numbers are just numbers that the only numbers that multiply to it is 1 in itself. Okay, so look, y'all, 2 is a prime number. That means every multiple of 2 is not prime. So I'm going to do this. I'm going to get rid of all the even numbers. Okay. And what I'm going to be left with, I'm going to keep playing this game all the way through. And look, y'all, I can do it this way because of how we wrote our numbers. Okay. Then the next prime number we have is 3. So then I'm going to get rid of every third number. like 6 and 9 and 12 and 15 and 18 and 21 and 24 and 27 and 30 and 33 and 36 and 39 and 42 and 45. I'm getting rid of every third number because every third number is not going to be prime. Okay, 60 and 63 and 66 and 69 and 72 and 75 and 78 and 81 and 84 and 87 and 90, 93, 96, and 99. Okay. Now, if you look, we've already scratched out 4. So we don't want to scratch out 4 because we don't need to, but we're going to keep 5. And then we're going to get rid of all the numbers that can be divided by 5. So the 15, 25, 35, all of these right here, as well as all of these right here, which we had already gotten rid of. Okay. Then the next prime number I have, y'all, is 7. So I'm going to get rid of multiples of 7, like 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, and I want to say 91, right? 84 plus 7, yeah, 91, and 98, which we had already gotten rid of anyway. Okay. And then what's the next prime number I have on my list? Oh, look, 11. So let's get rid of 22, 33, 44, 55, 66, 77, 88, and 99. The next number on my list, y'all, is 13. So I'm going to get rid of 26 and 39 and 52 and 65 and 78 and 91. Okay. And what I'm trying to do here, y'all, is it's kind of like I said, like a sieve. I'm trying to pour out the water in the noodles and just be left with the noodles, and I'm getting rid of the water. And the water are the numbers that I'm scratching out. So look, the next one we have, y'all, is 17. So 34, 17, and that would be 51, would be 68, and 17 would be 85. And okay, I think we're good there. And then the next one is 19. So I'm going to get rid of 38. And another 19 would be something like 57, which we'd already have. And we're going to get rid of another 19, which would be something like 70, 76, which I think we already got rid of. And another 19 would be 95, which we had already gotten rid of. Okay. And the next prime number on my list, you guys, is 23. So I'm going to get rid of 46. Add 23 to that, 69, which I think we had already gotten rid of, and add another 23 to that, 94, which we already gotten rid of. Okay, so look at the next prime number on my list, you guys, 29. And I think at this point, we've probably already gotten rid of a lot of the numbers, but I just want to make sure 29 times 2 is 58, which we got rid of. 29 times 3 is 87, which we already gotten rid of. Okay. The next one I have, y'all, is 31. Okay. So we'd have to get rid of 62, and we'd have to get rid of 93, which we had already gotten rid of. Okay. And then look at the next one, y'all, 37. And the next one is 41 and 43 and 47 and 53, 59, 61, 67, 71, 73, 79, 83, and 97. Okay, so what are those? Those are the prime numbers that I'm left with. The prime numbers between 2 and 100 are the ones that we've circled, okay? So let's do this. I'm going to try to make a little list over here, okay? And the reason I want to do that, y'all, having this list is going to make things easier for me. 2, 3, 5, 7, 11, 13, 17, 19, right? 23, let's see, 29, 31, 37, 41, 43, 47, let's see, 53, 59, 61 and 67, 71 and 73, and 79, and what, 83 and 97? Okay, so what did I do here, guys? We just made a list of the first prime numbers between 1 and 100. Those are the prime numbers, right? Now, guys, I'm a Google guy, right? So part of me says, hey, why don't I just say, let's go to Google. What are the first prime numbers between 1 and 100? Because I kind of wanted to show you this process. And this is kind of, it's a neat process because it shows you how you can find prime numbers. And one of the things that y'all will be doing when you're teaching, you know, anywhere between K to 8th grade is there's a process, there's kind of like repetition, right? How do you do this? You multiply, right? So that's kind of why I wanted to show you that. And again, that's why I said you don't have to copy this stuff, but I really want you to at least have those numbers right there in black because I'll be able to use that as a reference, right? And again, I can always Google it. Okay, but the reason I wanted to do that is the next problem here, it says to test to determine if a number is prime or composite, take the square root of the number and find the biggest prime number closest to the integer closest to the square root. Okay, let's see what that means. So look, guys, I want to find whether or not, it says, what's the greatest prime you must consider to test whether 8,964 is prime? So what I'm going to do is I'm going to take 8,964 and I'm going to take the square root of it. So look at the number that I came up with, 94 and change, right? What's the first prime number that's closest to 94 but has to be smaller than 94? What's the first prime number that's closest to 94 in my list right here? 83, and there's my number, right? Now, guys, had I not come up with this list, it would have been kind of difficult for me to find, right? Now, I want to make something up, guys. If the problem in your homework gives you a number that's, say, bigger than 97, then what I would do, I would say, okay, what's the first prime numbers between 2 and say 150? Do something like that so you can find that prime number, okay? All right. Now it says test whether the number 147 is prime, okay? So look, guys, I'm going to do the same thing. I'm going to come back over here. I'm going to take 147. I'm going to take the square root of it. So I'm coming up with 12, okay? So what's the first prime number that's smaller than 12? 11. Okay, so all that means, guys, it doesn't mean that my number here is prime. What it means is with my number 147, I'm going to check by dividing by any of those numbers right there. Okay, but the first one I'm going to try is 11. So look, let's take 147. Let's divide it by 11. No, it doesn't go in. Okay, so then what's the next number I'm going to try in this case? 7, right? I'm just going to kind of keep going down my list. So I'm going to try, I'm going to take 147. I'm going to divide it by 7. Okay, 21. Okay, hey, it works out. So that means that we can break up this number here into 7 and 21, and we can break down 21 into 3 times 7. So the question is the number 147 prime? No, it isn't. Why? Because we could break it down further, right? That's how I know it's not prime. Okay. All right. So the next problem that I have here, y'all, says find the least natural number that's divisible by 3 different primes. Okay. So first thing I want to mention here, y'all, on this problem is it says we're looking for the least natural number. Remember what that means? We're looking for the one that's going to be the smallest because it's the least, right? And it's supposed to be divisible by 3 different primes. So y'all, this is all I'm going to do. I'm going to come back to my list of prime numbers right up here, okay? And I'm going to say, what are the first 3 prime numbers that I have? 2, 3, and 5, right? So right there, you guys, I'm just going to say, look, if we take 2 times 3 times 5, those are all prime numbers, and they're the smallest ones. And if I multiply that out, that's going to give me 30, and that's going to be the smallest number that I can divide by 3 different primes. How do I know that? Because we took the 3 smallest primes. Okay. All righty. So there's something called the fundamental theorem of arithmetic, y'all, and it says each composite number can be written as a product of primes in one and only one way, except for the order of the prime factors in the product. Okay, so let me just give you an example of what they're talking about here. If I think of a number like, say, 36, does anybody know any 2 numbers that multiply to 36? Any 2? 6 times 6. Okay. Can we break down 6 into what? 2 and 3, and this is also 2 and 3. Okay, so y'all, if we were to rewrite this with the smallest numbers coming first, how many 2s do we have? 2. And how many 3s do we have? 2, right? Okay, so before I go on, I had asked, do you all know any numbers that multiply to 36? And you said 6 times 6, which is perfect. Do you know any other numbers that multiply to 36? 3 times 12? Okay, we can't break down 3. Can we break down 12? 3, okay, 2 and 6, perfect. And we can break down 6 into 2 and 3, right? Do you all agree we still have 2 2s and 2 3s? What they're saying here, guys, is when you're breaking this number down, how do you break it down really isn't important. You're going to get the same answer either way. Whether you say 6 and 6, whether you say 3 and 12, whether you say 4 and 9, you're still going to get 36, right? You could say 2 and 18. You're still going to get 2 2s. You're still going to get 2 3s. The order in which you do it and how you break it down is not important. The only way you're going to come up with a different answer and the wrong answer is if you take 2 numbers that just don't multiply to 36, right? But you're always going to get the same thing when you break down your numbers, okay? Okay, so let's see. On this next problem here, y'all, it says use the fundamental theorem of arithmetic to justify parts A and B. Okay, so all this right here is saying, and actually, guys, I'm going to do it this way. I'm going to come back to my Blackboard page, and I'm going to click on, I want to actually click on the actual assignment. I did like a little copy and paste here because this is like a drop-down menu, but sometimes it gets a little messy. And so I figured the easiest thing for me to do is actually do that problem just to kind of show you through the process, okay? All right, let's see, 4.2, here it is. I think it's number 6, but I don't know for sure. No, we already did that one. It's got to be number 7. Yes, okay. So look, guys, the numbers are a little bit different, but it's going to be the same sort of process, okay? So look, if 7 divides n and 3 divides n, then 21 divides n. Okay, so it says the fundamental theorem of arithmetic states that n can be written as a product of primes. That's why when I do the drop-down menu, when I pulled it up here, it's kind of hard to see which one goes where. So I just figured it's easiest to do it this way. So this is going to be a product of primes in one and only one way. And since 7 divides n and 3 divides n, and since 7 times 3 are both what kind of numbers? They're both prime, right? How do I know they're both prime? Because both of those numbers, y'all, both of those numbers are in my list right here, 3 and 7, right? Those are my prime numbers, okay? So let me just scroll back. Okay, let's come back to the problem. And they must be included in the unique factorization, right? Because we're not adding, we're multiplying numbers here. And then since, are we adding or are we multiplying? We're multiplying, right? 7 times 3, what's 7 times 3 anyway? 21, right? So look, I'm gonna go chickadee check, and we got it. There's 3 parts to this question though. Okay, since 4 divides n, and since 25 divides n, and since 4 and 25, I want you to think about the number 4. Can you break down 4 at all? Put 2 and 2, right? And can we break down 25 at all? 5 and 5, right? So guys, if 4 is 2 2s and 25 is 2 5s, this is going to be the products of different prime factors, right? Because 2 and 5 are different. And they must, and I want you to notice, look how I have it here. 2 squared times 5 squared. Why? Because 4 is 2 squared, right? And right here, y'all, we're going to say 2 squared times 5 squared is equal to 100, right? Okay. And there's the last part. Okay, so it says, is it always true if A divides n and B divides n, then A times B divides n squared? Yes, there's always going to be a whole number, guys, a whole number so that we can divide this thing out. I'm going to check it, and we're good. Okay, so I just kind of wanted to go through that one problem. Again, it was a little messy when I did it here, so I wanted to make sure that we were good on this one. Okay. Okay, so I'm going to keep moving along here. We're still looking for the factorization of these numbers. So again, y'all, just like we did in the other problem, I'm going to break these numbers down. When I see 22, I think of 2 and 11. Now remember, that's being raised to the third. Does anybody know what two numbers multiply to, say, 26? Can you divide 26 by 2? What do you think? 2 and 13, right? Very good. Okay, what about 25? Can we break down 25 at all? 5 and 5, right? And that's to the 14th power. Okay, so look, y'all, what I'm going to do now, we're going to go ahead and distribute those powers, right? So the power is going to go here, and the power is going to go here. That's 2 to the third, and that's 11 to the third. And this is 2 to the 19, and that's 13 to the 19, okay? Now, y'all, 5 times 5 is the same thing as 5 squared being raised to the 14th, okay? We're going to fix that part in 1 second. What we're going to go ahead and do, there's a rule, y'all, that says when you're multiplying two numbers with the same base, what we're going to do with their exponents, we're going to add those exponents together. Does anybody know what's 3 plus 19? 22. Okay, so there we go. Okay, and then I have an 11 to the third, and we have, I'll write my 13 to the 19 over here. Now, remember, y'all, we had another rule that says if you have a power being raised to a power, you can multiply those exponents together. So 2 times 14 should give me something like 28. Okay, so are we good on how I got to this part? No? Okay. So what I'm going to do with this guy here and this guy here, I'm just going to add their exponents together. So 3 and 19 gave me 22. Okay. The 11, I didn't do anything with it. I just wrote it down, right? The 13, same thing. I just wrote it down. And then these two, y'all, end up getting multiplied. And that's how we got our 28. So now I'm going to look at my answer right here. Okay. And I'm going to come back and I'm going to look at, okay, do I have that in my list anywhere? So 2 to the 22, 11 to the third, 5 to the 28, and 13 to the 19. Does it look like B? Right? 2 to the 22, 5 to the 28, 11 to the third, 13 to the 19th, B. The order in which you put them, y'all, isn't really important. They're putting it in order from smallest to biggest. That's what I meant to do. I just put my 11 and my 5 in the wrong spots. But the order in which you put it in really is not important. Okay. All right. We're going to do the same thing here, y'all, with the next problem. Okay. So we're going to try to break these numbers down. We're going to break them down real slow. Okay. 5,000. Okay. You guys agree that's the same thing as 5 times 1,000? Okay. And 4,500. Isn't that the same thing as 45 times 100? Okay. Now, I'm just going to keep working here, guys. I'm going to try to break my numbers down into prime numbers, okay? So look, let me think of the number 1,000. I'm going to do this on the side, okay? So if I think of the number 1,000, that's going to be 10 times 100, but 100 is the same thing as, what, 10 times 10? Okay, can I break down each of those 10s, though? We can break each of them down into 2s and 5s. So how many 2s are we going to have? What, 3 of them? right? And how many 5s do we have? 3 of them as well. Okay, so look, y'all. I'm going to leave this 5 alone. I'm going to have a 2 to the third, a 5 to the third, raised to the 40. Okay, we're going to fix some stuff in a minute, right? I'm not done yet. Let's do the same thing with 45 and 100. Okay, so look, I'm going to come back over here. I'm going to break down 45. Anybody know any two numbers that multiply to 45? 5 and 9? Okay, we can't break down 5. Can we break down 9? 3 and 3, right? Okay, and then we also had 100, didn't we? And 100 we said was 10 and 10, but we can break up each of those 10s into 2s and 5s, okay? So look, y'all, I'm just going to come back over here, and we're going to say 45 was a 3 squared and a 5, and 100 had 2 2s and 2 5s, okay? All right, we're almost done. I'm going to leave this 2 to the third alone, y'all. If I have a 5 here and I have another 3 5s over there, y'all, that's just telling me we have a total of 4 of them, okay? I'm going to leave these 2 2s alone, so 2 squared. I'm going to leave those 3s alone. If I have a 5 here and I have another 2 5s there, don't we have a total of 3 of them? Okay. We're almost done here. Guys, remember the next step. The next step says we're going to multiply the powers. So that's going to go there and that's going to go there. Okay. Anybody know what's 3 times 40? 120. Very good. Okay. What about 4 times 40? 160. Okay. Times, let's see. We're going to do the same thing here, y'all. Okay. 2 times 29. Is that 58? Okay. And 2 times 29 again should also be another 58. Okay. Y'all, what about 3 times 29? I want to say that should be something like 87. Okay. Now, coming back to my rules of exponents, y'all. I'm going to take this 2 right here and this 2 right here. If I have 122s there and I have 58 2s there, that's telling me that I have a total of, I'm going to add them together, 178 2s. Okay. My 3s, there should be a total of 58 of them. And then my 5s, look, y'all, if I got 160 and 87 over there, I'm going to add those numbers together. Is that 247? Okay. And then I'm going to look at this right here, and I want to come back and look at my choices. And is that one of my choices up there? Maybe choice A? There we go. Okay. These problems right here, y'all, I don't want to lie, they take a little bit of time because you got to break the numbers down, and then you kind of have to go back and use those little rules of exponents to see, hey, how did I get from this part to that part? Okay. So one thing I want to mention, y'all, and I'm going to just pull this up real quick because I think I have it still up on here. Here we go. Okay. When you have a power being raised to a power, you multiply them together. When you have like a certain number of 2s here and a certain number of 2s there with the exponents, you just add them together. Okay. So that's the part that I really kind of want to emphasize. That's really what I'm doing. We're adding the exponents or we're multiplying them. How do I know when I multiply them? When I have a power being raised to a power. But if I just have a certain number of 2s and another certain number of 2s, I add my exponents. Okay. Okay. So let me take a look at the next problem. I'm going to write it down over here to the side, y'all, because I'm kind of running out of room. So, let me just write it down over here. So we have 2 times 3 squared times 5 to the 105th times 7 plus. Okay, guys, I'm going to rewrite that 4. What's another way I can write 4? 2 times 2, which is the same thing as 2 squared, right? Let's see, times 3 squared times 5 to the 105th. Okay, so what we're trying to do, we're trying to find a correct factorization of this thing here. Okay, so y'all, the way we're going to find a correct factorization is I'm going to look piece at a time. Okay, I got kind of one piece right here and one piece over here. Okay, so as I go piece at a time, this one has 1, 2, but this one has how many? Has 2 of them, right? Okay, I can only take as many as they can both give. What I mean by that, y'all, I can only take 1, 2, because this one only has 1, even though that one has 2, they can both only give up 1. So look, I'm going to take away a 2. And they both have a 3 squared. So I'm going to take away a 3 squared. And they both have a 5 to the 105th. So I'm going to take that away. Now, if we took, do y'all agree we took everything away from here? Except what number? The 7. So the 7 is going to stay right there. Okay. Now, we took all the 5s, we took all the 3s, but we were left with what? A 2. Okay. So look, y'all, I'm going to keep going here. I'm just going really slow. Okay. Anybody know what's 7 plus 2? 9. Okay. Is there another way for me to write 9? 3 times 3, right? Or the same thing as what? 3 squared? Okay, so now I want to show you something here, guys. We have 1, 2. Look, if I have 2 3s there and I have another 2 3s there, we have a total of 4 of them. So this right here should be my answer. 2 times 3 to the 4th times 5 to the 105. And I'm going to scroll back this way. Here we go. 2 times 3 to the 4th times 5 to the 105. And there's my choice right there. Okay. Okay. So for the next one here, y'all, it says find the correct factorization of 2 times 3 times 5 times 7 times 11 plus 1. Whew. Okay, let's see if we can figure out what that number is to begin with. Let me clear this out. 2 times 3 times 5 times 7 times 11 plus 1 is 2311. Okay, so the number I'm coming up with is 2311. Now, y'all, if I wanted to figure out if I could break down that number, remember what I would do? I would take the square root of it, okay? So I take the square root of it, I'm coming up with 48. So then what I would do, y'all, is I would scroll back up here where I had my list of primes, and the number that I had was 48. So the first number I would check to see if I could divide it by would be 47. And I'm not saying that it's going to be divided by 47, but I'm going to check all the numbers 47 and smaller, okay? So, oops, let's do this. 2311. Oops, let's do 2311. Let's divide it by 47. Nope, 2311. Let's divide it by, what, 43? Nope, 2311. Let's divide it by 41. Nope, 2311. Let's divide it by 37. Nope, 2311. Let's divide it by, what was it, 31 maybe? Yeah, 31. Nope. This might be one of those prime numbers, right? 29. I just want to check. Divided by 23. Nope. Divided by 19. Nope. Divided by 17, I think was my next one. Nope. I got a strong feeling, guys, that we cannot break this down. Nope. Okay, I know I can't divide it by 5, and I know I can't divide it by 2. Nope. Okay, so we can't break it down, right? So if I scroll back down here, you guys, and it says, what's the correct factorization? 2311, right? We just can't break it down. Okay. Alrighty. So next part here, guys, says if 64n equals 2 to the 7th times 3 to the 6th times 5 to the 3rd times 7 to the 5th times 11 to the 4th. It says explain why 2 times 3 times 5 times 7 times 11 to the 3rd is a factor of n. Okay, so first thing I'm going to do, I want to look at my number 64. Okay. Anybody know any two numbers that multiply to 64? 8 times 8. Perfect. Can we break down 8? 2 times 4. Can we break down 4? 2 times 2. Good. We're going to do the same thing here, y'all. 2 times 4, and 4 is 2 times 2. Okay. So 64 is the same thing as 2 to what power? How many 2's did we have there at the end? 6, right? 1, 2, 3, 4, 5, 6. Okay. So 64 is the same thing as 2 to the 6. Okay, so y'all, I'm going to look at my answer choices here, okay? So look what it says. Part A says rewriting 64 as 2 to the 6 and dividing leaves. Let's see. I want to show you something, y'all. If I look at this piece right here. Now look, I have a 2 to the 6, right? I have a 2 to the 6. How many 2's did I have here? And I had 7, right? If I take away 6, would you guys agree that I'm left with 1, 2? Right? I didn't change my 3's. I didn't change my 5's. I didn't change my 7's. And I didn't change my 11. So my answer here is going to be choice A. Why? Because if 64 is the same thing as 2 to the 6th, and we had 2 to the 7th, that should mean that there's 1 extra 2 left over. Okay. All right, now let's take a look at the next one here. It says, is 3 to the 5th times 5 squared a factor of 3 to the 6th times 5 squared? Okay, how many 3's do we have here, you guys? We have 6 of them, right? How many are we taking away? We're taking away 5 of them. So look, 3 to the 6th is the same thing as 1 3 with another 5, because if I have 1 right there and another 5, there's my 6, right? So the reason why 3 to the 5th is 5 squared is a factor of 3 to the 6th 5 squared. Don't worry about the 5's because they're the same 5's. But as long as this power here is smaller than that one, then it's always going to be a factor. Okay. Okay. So y'all, for this next problem, it just says Mr. Arboreta wants to plant fruit trees in a rectangular array. For each of the following numbers of trees, find all possible rows if each row is to have the same number of trees. Okay, this is how we're going to do this, y'all. We're going to take the number 196, and we're going to find the prime factorization of that, okay? So 2, I know I can divide it by 2. 196 divided by 2 is 98, okay? And then we're going to divide that by 2, and that should give me 49. And we can divide that by 2, and that's going to give me 7 and 7. Okay, what we're going to do here, y'all, we're going to play a game. We're going to find all the numbers that we know multiply to 196. Okay, so look, y'all agree 1 and 196 would multiply to 196? Okay, I got another one, 2 and 98. Okay, I got another one. Let's see, 2 and 2 is going to be 4. So look, y'all, and what I'm really doing here, you guys, just to kind of let you know the approach and how I'm doing this, I'm saying, look, if I were to pair these numbers up together, 2 and 2, then wouldn't the numbers be left with would be 7 and 7, so 4 and 49? Do you kind of see the little game I'm playing? I'm trying to do every possible combination. Could we do this? Look, 2 and 7 is 14. 14 and what? Well, 14 and 14, right? Because if I pair those two up, then I got to pair those two up, right? And really all I'm doing here, y'all, I'm just trying to find all the pairs of numbers that multiply to 196, right? How did I do that? Number one, I always know it's 1 and 196. And then it's 2 and 98, or it's 4 and 49, right? Or it's 14 and 14, right? That kind of thing. That's really the game that I'm playing here, okay? And I believe those are all of our choices. Now, look, let's try part B. The number of possible rows for 18 trees. Okay, so look, y'all, first off, I already know 1 and 18, right? But look, let's break down the number 18, okay? What two numbers do you know multiply to 18? 2 and 9. Okay, can we break down 9? 3 and 3, right? Okay, so look, let's make some pairs here. Do you guys agree 2 and 9? Okay, if we did 2 and 9, could we also do this 3 and what else? 3 and 6, right? And those are all my choices. Okay. Okay, 23. Anybody know any two numbers that multiply to 23? 1 and what? 23, right? But guys, isn't 23 one of those prime numbers? Like nothing multiplies to 23 besides 1 and 23? So that's all I'm having here, right? Okay, and we got a part D, 144. Okay, so look, y'all, let's break down the number 144. Y'all agree that's 12 and 12? Oops. 12 and 12, let's see, 12, oops, come on, pen. 12 is the same thing as 2 and 6, and 6 is 2 and 3. Okay, so y'all, this is going to be a little bit of a longer list. 1 and 144, okay? Again, I'm just going to start playing a little game here, y'all. Look, 144, I'm going to divide it by 2. 2 and 72. Let me divide it by 3. 3 and 48, okay? Let me try dividing it by 4. 4 and 36, okay? I can't divide by 5, but we can divide it by 6. 24, okay? Let me try dividing it by 8. 8 and 18, okay? Let me try dividing it by 9. 9 and 16, okay? And I believe that's where we're going to have to stop. I don't think we can have any other numbers that are going to give us 144. But this is all we're really doing, right? That's all we're really doing there. Okay, so this is the last problem y'all hear out of 4.2. And it says, a woman with a basket of eggs finds that if she removes the eggs from the basket, either 3 at a time or 7 at a time, there's always one egg left. However, if she removes the eggs at 11 at a time, there's no eggs left. If the basket holds up to 100 eggs, how many eggs does she have? Okay, let's think about it this way. Anytime there's a certain number of eggs there. Anytime she takes out 3 at a time, there's always one left. So let's think about the multiples of 3. Multiples of 3 would be like, what's 3 times 1? 3, right? But there's always one left. So that would mean I'm thinking about 4 eggs, right? Because if I took away 3, there'd be one left. What's 3 times 2, you guys? 6. But one more is going to give me 7. So look, I want just to kind of show you what I'm doing. I'm going to come back over here to my multiplication table. I'm going to take these numbers here, y'all, and I'm going to write them down, but I'm going to add 1 to each of them. And I'm not going to go further than, I'm going to make sure that the last one I stop with is right before 100. Okay. So look, the next one would be 9, but one more is 10, 12, and one more is 13, 15, and one more is 16. Guys, am I just adding 3 to each of these numbers? Yeah, right. So what's the next one? 19, 22, 25, 28, 31, 34, 37, 40, 43, 46, 49, 52, 55, 58, okay, let's see, 61, 64, 67, 70, 73, 76, 79, 82, 85, 88. I'm going to stop because it says it holds up to 100 eggs, so I want to make sure I don't go over 100. 88 and 3 should be 91, 94, 97, and I'm going to stop right there at 100, okay? Now, y'all, the same thing happens if we were taking out our eggs 7 at a time, okay? So look, I'm going to come back to my multiplication table. I'm going to look at 7. I'm going to write each of those numbers, but I'm going to add 1 because it always tells me about when I always take out 7, I'm always left with 1, okay? So look, let's make our list for the 7s. Okay, so 8, 15, 22, 29, add 7 to that. What is that? 36. Add 7, 43, 50, 57, 64. Add 7 to that is 71, 78, 85. Add 7 to that is 92. And add 7 to that is 99. Okay, what I want to do, y'all, I want to do a little stare and compare. I want to look at those two lists. Do we have any numbers in common? In the green list and in the blue list? 22? Looks like a number we have in common. Is that the only one we have in common? 43? Yeah, 43 as well. And what? 64? And 85, right? Okay, those are the numbers we have in common. All right, so I'm going to look at those numbers, 22, 43, 64, and 85. Now, the last part says, if she removes eggs at 11 at a time, there's none left. Which one of those numbers is divisible by 11? That's how many eggs she has, right? So we're going to say she has 22 eggs, right? And that's how we did that problem, okay? So, you guys, when you're doing your homework problem, you know, are you always going to get 3 and 7? No, you might get like, you know, 5 and 7. But you're going to look at those multiples. Remember, you're always going to add 1, and then you're going to look at the number, find the ones that have in common, and then which one can be divided by that number there, nice and pretty. Okay. All righty, so let me go ahead and stop hitting record.